to the counting principle. The counting principle allows us to determine the number of possible outcomes of an event. And there are more than one way to do this. We can do this with a tree diagram. Or we can use math. Okay, and the event is known as a compound event when we need to do this versus a single event. Okay. A single event occurs when you have one choice to make. So, for example, picking what you're going to drink out of a possible 5 different kinds of drinks. You can pick one. There's 5 options, 5 possible outcomes. A compound event occurs when you have 2 or more choices to make. So for example, pizza. You're about to order a pizza. Perhaps you're going to a specialty pizza place and you can choose between different kinds of crust. White, wheat, whole grain, rye, pumpernickel, sourdough. And then you can choose your sauces. They have marinara and meat sauce and Alfredo sauce and barbecue sauce and all kinds of different sauces. And then they have a lot of different kinds of cheeses. And then they have different meats. And then they have different vegetables. So this is when you have a compound event because you have 2 or more choices to make. So let's look at that. Let's say pizza. We're going to order a pizza. And we want to figure out how many possible pizzas exist. Okay, we're going to go with a simpler example. We'll say we have 2 crusts, white or wheat. We have 3 sauces, marinara, meat, or Alfredo. And we'll go with 2 cheeses, mozzarella, or cheddar. I know that sounds actually kind of gross, but we'll just say that. And then 4 meats, pepperoni. Actually, we'll skip the meat for now. We'll just say we'll do 3 cheeses because I don't want to make this too intense our first time around. So we'll have mozzarella, cheddar, or provolone. Okay, so if we get a white crust pizza, we can choose marinara, we can choose meat sauce, or we can choose Alfredo. And if we get a wheat crust pizza, we can choose marinara, we can choose meat, or we can choose Alfredo. Once we've chosen our sauce, we have 3 different kinds of cheeses, mozzarella, cheddar, or provolone. And we can choose mozzarella, cheddar, or provolone for any of the sauces that we pick. So we can have a white marinara with mozzarella, or a white marinara with cheddar, or a white marinara with provolone, a white meat with mozzarella, white meat. So you can see this last row gives us the total number of possible choices. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 possible pizzas. And this was our tree diagram. Now let's take this and try to expand it. We'll have our 2 crusts, white or wheat, 3 sauces, marinara, meat or Alfredo, 3 cheeses, mozzarella, cheddar, or provolone. And now let's add meat. Well, let's see, we've got pepperoni, sausage, ham. Some places do ground beef. Some places do chicken. So that's what, 5 meats. And then we have vegetables. Well, our basics, we have onion, mushroom, peppers, well, green peppers. We can also have hot peppers. We can have olives, black or green. So we'll do black olives, green olives, tomatoes, pineapple, because some people like that on their pizza, pepperoncinis, onions, mushrooms, peppers, hot peppers, black or green olives, tomatoes, pineapple. Well, we'll go with that. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 possible vegetables. Now, making a tree diagram with all of this information can be very time consuming. It takes up a lot of space. So it's not the most efficient method, and this is when we'll use math. And what we'll do to determine how many possible combinations of pizza we are, you take each choice. So we have crust, and we have sauce, and we have cheese, and we have meat, and we have vegetables. And we multiply this number together, and this will give us our total number of possible pizzas. So 2 times 3 times 3 times 5 times 9 gives us 810 possible combinations of pizza. And that is if we pick 1 crust, 1 sauce, 1 cheese, 1 meat, and 1 vegetable. When you add in the multiple vegetables, you have to account for those as well. So for right now, just with 1 sauce, 1 crust, 1 cheese, 1 meat, and 1 vegetable, that's 810 possible pizzas. And that is known as the fundamental counting principle. So this is how you figure out the total number of combinations. Let's try another example. Let's say you're trying to figure out how many different outfits you have. So you'll have a top, and you'll have a bottom, and let's say you have an accessory. That could be a tie or a scarf or a belt or, something. Well, let's say you have 15 tops to choose from, and maybe you have 9 bottoms and 20 accessories. You can figure out how many different possible outfits you can make with that by multiplying those numbers together. So you have 15 times 9 times 20. There are 2,700 possible outfit combinations. Now maybe they don't all match, but you could put this together in 2,700 different ways. Let's go with lunch. Let's say you have a choice of 5 different sandwiches. Let's look at the possibilities in the new fountain drinks where you can add the vanilla and stuff. We'll just say 21 drinks. I have no idea how many they actually have, but 21 drinks. And let's say 5 sides. So if we want to figure out how many different lunch combinations we could have, let's say you get to pick 2 sides. This is side 1. There's a choice of 5, and then you can pick a second side that means you have 5 choices again, because you could pick double of anything. So let's say you decided potato salad, so you get twice as much potato salad. So we have 5 sandwiches, 21 drinks, 5 of the first side, 5 of the second side, and that gives us 5 times 21 times 5 times 5. That's 2,625 possible lunches. Now let's say you can't pick 5, you can't double up on your side. That leaves you down to 4, because once you've picked the first side potato salad, then you're having to pick from the other 4 sides for your second side. Now that would limit us very slightly to 2,100. So I guess not that slight. So if you can't pick double sides, you lose 525 different possible combinations.